Hello friends, I hope you're all doing well, in a good health condition, and studying well, of course. Today we are moving to section 3 of chapter 5. It's about definite integration and fundamental theorem of calculus. Previously we have studied the indefinite integration. Okay, what was indefinite? Indefinite integration. It was the integration of the kind like that, okay, f of x dx. When we were getting the result of that, it was capital F of x plus c. In general, when we were talking about indefinite integration, the integration that we had, it didn't have bounds, no lower limit, no upper limit. But in definite integration, I will have a bound here, a number here, and a number there. How do we calculate that integration? It will have the same procedure as we did for this one, but instead of writing that plus c, we have to substitute the numbers that we have got into the result that we get from the integration. So in general, when I have got integration from a to b, that means it is given in an interval, okay, f of x dx the integration will equal to what? Of course, we're finding the result. It will be capital F of x, but I told you here we will find the integration. It will be f of x, and then I'm inputting that b inside it minus the integration. When I get the result, I will put a inside it. So instead of that, see, what do I have? I have got the function, and then I put b once into the function, and then minus, then I input a into the function that we have got. Okay. In general, when we are talking about definite integration, it is considered as the area between a curve and the x-axis. So let us make the subject, that is the fundamental theorem of calculus, area as a definite integration, integral, or we can say. What do I have here? I have got a function, okay, that's continuous on the given interval, okay, and then I have got a region, okay. The region that I have got is, for example, we have got the function is f of x like that, and then it's required from us to find, for example, that area, okay. It's required from you to find that area. To find that area, what do we use? We use integration. So how do we use that? We say that integration of f of x, okay, from a to b. So when we see that integration, that means we are finding the area between a curve, okay, and the x-axis. So that's called what? That's called area as definite integration, okay. And of course, you're solving this one as you solve this one, and of course this one is solved as we have studied in indefinite integration. Let's move to the examples that are given to us, okay. Example 5.3.2. It says find the area of the region under the line y equal to 2x plus 1 over the interval 1 to 3. Okay, so what's required from us? It's required from us to find the area. Since area is required from us, so what do we have to find? We have to find the integration, okay, because area means definite integration. So that one we get integration of the function that is given to us is 2x plus 1 dx, okay. And what is the interval that's given to us? It's from 1 to 3, okay. So that is the area. It is okay, it can give you the question as area, find the area of the line over that interval, or it can give you that evaluate that integration. So if you have got this integration, or if you have got that piece of writing, it gives the same meaning, okay. So how do we do that integration? Take away the bounds and do the integration as we did usually for the indefinite integration. What is the integration of 2x? It is 2x squared over 2, okay, plus What is the integration of 1? It's equal to x. Now instead of writing plus c, I will write the integration runs from 1 then to 3. Okay, now what do I have to do? I will do first the simplification before inputting those numbers. So that one will be x squared, these two will cancel each other, plus x, and the integration runs, the bound runs from 1 to 3. Now I'm inputting the numbers according to this one. When I found the function, that's the f of x, the capital F of x that we have found, first we are inputting 3 into the function. Look, we are inputting the upper bound, so that will be x squared, 3 squared, okay, 3 squared minus, plus 3 minus, okay, we have got from the rule, when we put the upper bound, then we have got a negative sign here, then we are inputting the lower bound for this function, so that one will be 1 squared plus 1. 3 squared is equal to 9 plus 3, that's equal to 12, okay, and then we have got minus 1 plus 1 is equal to what? Is equal to 2. So 12 minus 2 is equal to 10. So the area between that function over that interval of that region is equal to 10. That's all about definite integration. So you're doing the same procedure that you were doing for indefinite integration. Okay, you're finding the integration that we had, the rules of integration. But instead of plus c, we have got a bound and we have to input those values that will be given to us. Our next example is again finding the area, okay, under the curve y equal to x to the power of 3 plus 1 over that given interval. We are doing the same procedure since area is required from us. So that means we are finding the definite integration of x to the power of 3 plus 1 dx over the interval from 0 to 1. That's again easy. We are finding the integration as we have no bounds for the integration. What's the integration of x to the power of 3? It is x to the power of 4 over 4 plus integration of x. Integration of 1 is equal to x, and instead of c, we are writing the result is from 0 to 1. First, according to definite integration, we have to input 1 into the function. So that will be 1 to the power of 4 over 4 plus 1. And then we have got a negative sign from the rule. Then 0 to the power of 4 over 4 plus 0. Okay, that bit is all equal to 0. Okay, that one is all 0. So that one is equal to what? Is equal to 1 over 4 plus 1. Equalizing the denominators, that will be 1 over 4 plus 4 over 4, because we know this one has got 1 in the denominator. We are multiplying numerator and denominator by 4, so that one will be 5 over 4, and that's the required result. Okay, we've got another example, but it is not required for me to find the area. It's evaluation of a definite integration, but of course it is giving the same result, the same steps that we have done previously. Evaluate the integration from 0 to 1 e to the power of minus x plus root of x all dx. Okay, so if it says find the area under that curve over that interval, or if it gives you as an integration, you're doing the same steps. So if you look at this one, what is the integration of e to the power of minus x? We know that if you have got e to the power of kx, that's equal to 1 over k. Okay, so that will be minus e to the power of minus x. What is integration of x to the power of 1 over 2? That's x to the power of 1 over 2. Since it is integration, so the power will be increased by 1 over the power, so that will be plus 2 over 3 x to the power of 3 over 2, and the integration runs from 0 to 1. Okay, why this became like that? Because integration of this one let me write here, integration of x to the power of 1 over 2 is equal to x to the power of 3 over 2 over 3 over 2. Then I made this one upside down to make it right next to here. It will be 2 over 3, and that will be x to the power of 3 over 2. Now we're inputting those numbers into the function that we have got. Of course, we're first inputting 1. So a to the power of minus 1 plus 2 over 3, 0 to, sorry, that is 1. 1 to the power of 3 over 2. Okay, this is 1 to the power of 3 over 2. Then we have got minus, then we're inputting 0 into the function, plus 2 over 3, 0 to the power of 2 over 3. Now, minus e to the power of minus 1 is equal to minus 1 over e, plus 1 to the power of 3 over 2 is 1, so that will be 2 over 3, okay, because 2 over 3 multiplied to 1 is 1. And then we have got minus e to the power of 0 is equal to 1. With that negative, it becomes plus 1, okay, and that part is equal to 0. Calculate those two together. That will be minus 1 over e, 2 over 3 plus 1, that is equalizing denominators by 3. So 2 plus 3 is equal to 5 over 3, and that is the required result. We've got another example. Again, it is evaluation of an integration. Example 5.3.5. Again, evaluate integration that runs from 1 to 4 of 1 over x minus x squared all dx. Okay. Again, integration of 1 over x is equal to ln of absolute value of x minus integration of x to the power of 2 is equal to x to the power of 3 over 3, and the integration is from 1 to 4. First, we have to input this one into here, so that will be ln of absolute value of 4 minus 4 to the power of 3 over 3. Then we have got minus from the rule, and then we are inputting this one into the function, minus 1 to the power of 3 over 3. Ln of 4 needs a calculator, so I will leave it like that. Minus 4 to the power of 3 is equal to 4 multiplied to 4 multiplied to 4. 4 multiplied to 4 is equal to 16. 16 multiplied to 4 is equal to 64 over 3. Minus ln of 1 is equal to 0, and that is minus 1 over 3. Rearrange this one, make it nicer, so that will be minus 64 over 3. That will be plus 1 over 3. Again, ln of 4 minus the denominators are equalized. Minus 64 plus 1, that will be minus 63 over 3, and that is the result. Okay. We have got some rules for definite integrals. Okay, the rules are the same thing as we have studied in indefinite integration, mostly, of course. We have got constant multiple rule. You're already familiar with that. We have got sum rule. That means if two functions are added or subtracted together, so the integration is for this one and that one. We have already solved those examples doing those rules. We've got difference rule. That means if it is subtracted from each other. Then we have got two more rules that is related with the definite integration. I will write only those two rules because the others are the same thing that were used for indefinite integration. Rules for definite integrals. So the first one, we have got constant multiple rule. I will not write it, okay? And then the second one, we have got sum and difference rule. The third one is difference rule, but I made it all together. Then the third one, we have got that integration. If I have got a definite integration that runs from a to a, that means 0 length. Look, it's from a to a, so the length of that interval is 0. That one is directly equal to 0. For example, if I have got integration from 5 to 5, if you look, the numbers are the same, okay? And that here I have got e to the power of minus x plus 1 over x minus, for example, x squared plus 10 dx. You do not need to solve that integration to say that's equal to minus 1 over minus e to the power of minus x, that's ln of x, that's x to the power of 3 over 3, that is 10x, and then inputting those numbers inside it. You're directly doing what? You're directly saying that that integration is equal to 0. Okay, you don't need to solve it. When you see it is running from the same number to the same exact number, you're directly saying that this result is equal to 0. Why? But you have to write the cos next to it because of that rule. Just write that rule next to this one, okay, as a cos. You will get your full mark from that question. But if it is from negative 5 to 5, you will not get 0. Look, the numbers must be the same. We have got another rule, okay? If you have got an integration from b to a, and I want to change the bounds, the limits of the integration. For example, I want to bring that a down here and the b to there. In the example, it is required like that, so that will be minus a to b f of x dx, okay? So if I have got an example like this one, from 3 to 2, for example, x dx, that's just an example, okay? I just want to change the bounds. I want to bring that 2 to here and the 3 to there. I will simply write a negative in front of it, bring the 2 to the lower limit and 3 to the upper limit x dx, and then you're simply solving the equation that will be given to you, the example I mean. Okay, we've got another example. 48. Okay, we have got example 537. In that example, it says evaluate that given integration. Here we have to use substitution method for that integration. So you're using the same things that we were using in indefinite integration. Here we are letting u, if you remember, we are letting that thing that's under the power, let u that's equal to x squared plus 1. After u, we have to directly find the derivative of that one, that's equal to 2x dx. And then what we were doing? We were changing the integration. That's equal to what? I'm not putting the bounds, okay? X squared plus 1 to the power of 3, that means u to the power of 3, okay? And then we have got, instead of 2x, I have got 8x here, okay? Because we have to change whatever x we have got in the integration into u form. So instead of having that 8x, I have got 2x here. If I multiply this one by 4, I will get the 8x that I need. So that will be 4 du is equal to 8x dx. So to change that 8x dx into something into forms of u, that's equal to 4 du. Okay? Now, if you solve that integration, I'm not putting these bounds in here. Why? Because that integration is changed from x to u. The bounds are given here are for x, it's not for u, so I'm not writing 0 and 1 here. Okay, so I'll leave the integration just as an indefinite integration. So that one is equal to what? That one is equal to 4. Okay, I have got a 4 out, and that one is u to the power of 3, I mean 4, because it's increased by 1, over 4. Okay, now this 4 and 4 go together, so I will have u to the power of 4. Okay, now I'm changing that u back to x. u is equal to what? X squared plus 1, and that's all to the power of 4. If you look at here, when it was u, I didn't put those bounds. Now I have changed the u back to x, and the bounds are for the x, so I'm putting the bounds right in here. So that one will be 1 squared plus 1 all to the power of 4 minus, that's 4, okay, not u, 0 squared plus 1 all to the power of 4. Solving this one will give you the required result. Let's solve it together. 1 plus 1, that's equal to 2 to the power of 4. 2 to the power of 4 is equal to what? It's equal to 16. Okay, minus, that's 1 to the power of 4, that's equal to 1, and the result is 15. You're given another example, but I think I will leave that example for you to do it yourself. Example 5.3.8. Again, an integration is given to you from 1 over 4 to 3, to 2 here. Ln of x over x dx. You let here, I will leave it for you in general, but I will just let you this one. Change this one to that form so that you see the result better. The equation. Okay, I'm first writing it as this form, ln x multiplied to 1 over x dx. Of course, if you're doing that multiplication, you will get this one. Okay, that will be ln of x. We said after this one we are directly inputting, finding the derivative of this one, that's equal to 1 over x dx. Of course, after this one, what are we gonna do? I'm changing the integration. Okay, look, I'm doing it simply for you, please. Okay, you do it step by step nicely. Ln of x is u. 1 over x dx is equal to what? Is equal to du. But I'm again not putting the bounds in here because the bound is given for x and not for u. So that one is equal to u squared over 2. Now we are changing the u back to x. Instead of u, I have got ln of x squared over 2. Now I'm putting the bounds. Why? Because I have got x here and the bounds are for the x. So that one will be ln of 2 all squared over 2 minus ln of 1 over 4 all squared all over 2. This one needs a calculator, so you will leave it just like that. That's all about section 3 of chapter 5, how to find the definite integration. We said what is the difference between the definite integration and indefinite integration. It's just, of course, you are having the same rules, doing the same steps for finding integration, but except of having that c here, we are inputting the values that are given to us into that f of x. Okay, and there's of course a negative sign between them. We said when we are talking about definite integration, we mean we are finding the area between a curve and the x-axis. So in general, if you write that area, if you say find that area or evaluate that integration, it gives you the same meaning, or you will get the same result in general. Hope you would enjoy watching that video. Have a good time and bye.